our machine shop. Today we're going to be working on a project, and it's a project for Keith Rucker, and it's a project that he was doing for the Veterans Railway Museum down in Bristol, Florida. A few months ago, Keith had called me and asked me if I could get a program for running these train wheels on a CNC lathe that he was going to borrow. Well, I got the program written, and the date came to go to the place and run the wheels, and they had trouble with the lathe, so we couldn't get them ran. So I volunteered to run them in my shop on a mill. We don't have a lathe. We have 7 mills, and you can do this on a mill, and we actually made 2 of them on a mill. And Keith came up, we ran a couple of them, 2 different days. I think we managed to get 1 each day, or maybe we got 2 one day, and we messed around the other day and couldn't get 1 ran. Well, a while back I'd made a video doing some indexing plates for Keith, and we talked about where CNC came into play and why it was so important, which jobs. Well, this is a lathe job. It's a pure lathe job. If you had a CNC lathe, it'd be perfect. But trying to run it on a mill, it's nothing but a problem. And there's several reasons for that. But anyway, I've had them here. I was going to continue to run them and work when I had time. But with the hurricane that came last month, holidays, and our customers are pushing for the end of the year, we're pretty much running our machines around the clock. So I haven't had time to do this for them. So what I've been doing is I'm running them here in my shop. I've got the tooling to do it. I've got a lathe to do it. It's a manual lathe. Even the manual lathe is better than the CNC mill. And the biggest reason is, and if you know about CNC and you know about mills, you understand the mill only moves in 3 axes. It moves Y, X, and so when it makes a circle, it has to calculate that X and Y move all the way around. Well, to do that, I think the program we wrote for it was 130,000 lines. Okay, and that was done in Mastercam, and it could have been done simpler. It could have been done with a radius and can cycles and things like that, but still it wasn't efficient. And the finish didn't look great. To get the finish to look great, we even had to slow it down more, and it was already taking like 3 hours to do this. So I can do it here on my lathe in about 45 minutes to an hour. So it's more efficient to do it here than to do on a CNC mill. So there's one of the things that's actually a lathe job is a lathe job. And now I could have done it on the 5-axis mills, but again, we're just so tied up and so busy. That's our busiest machines, and it just didn't happen. So I've been knocking them out here, and I'm gonna video doing one and let you know show you what there is into making one of these things. So you stand by. I got to take it over to the press, and well, let's see what. All right, when these things come to me, Keith had already done some work. He bored and reamed a hole. Okay, he faced this face, and he's faced this back face, and this face, and then this diameter here. So all the rest of it is ready to go. So now I have to take it over to the press and broach a hole in it. And when I'll come back, we'll mount it up on the lathe, and we'll start turning it. So stand by. As I got you over at the press, and the press area to me is a catch-all. So I got little projects all over the place over here. So what I have here is I have a 20-ton press, and set up. What we have a 1/4-inch broach, push broach. We have a 1-inch bushing, and basically we make the first pass. We make the first, and we have a shim. So we make our first pass without the shim, and I'm going to put it in my pocket where I won't drop it. So I don't know how many people have done broach work before, but you need to be as efficient as possible. So what I have here is I usually try to use a piece of aluminum. I got some aluminum blocks here, and you want to fill, by being efficient, you want to fill this whole, you want to use all the travel on your press. So what I've got is the 2 aluminum blocks, and then I've got a block sitting here in the middle, and I've got maybe an 1/8 of an inch that I'm not using. So and it's just a boring job. So on the second pass, we have to put a shim in the back, and this comes with the broaches. Okay, so right in front of my eyes. Alright, so we got the broaches, and alright guys, here you go. One broach keyway. I gotta go deeper. What we have here is we have a spindle I made. It's turned down to 1 inch. It's got a key in it, and it's threaded 1 inch 8 threads per inch. So it's got 2 registering surfaces. It's got the 1 inch shafts been indicated into within 1/1000ths, and this face here is been faced off square with this. And if some reason need to indicate why I have one on, this register right here has been turned to all of this. So what we're about to do now is we got a piece of pipe right here. Okay, and over. and just clean everything off real good. The registers, looks like we need to deburr a little bit back here. Okay. Anyway, everything clean, and Keith had reamed these, and some of them fit real good. Something like this one don't fit at all. So there's some trash in it. Make sure we don't have a burr somewhere. Still got a burr right there. Let's try it again. What I like to do, I'll spray a little bit of lube on there. That'll help get it off. Like I said, Keith had turned, face this side, and he faced this side here. So I'm gonna put an indicator on it, and let's see. All right, let's see how tight we are with it. Okay, like I said, Keith had faced the front, faced the back, and had bored the hole. So let's see how close our setup is to Keith's. Looks like we're maybe 5 thousandths off. So 5 thousandths on the front. We're going to use 3 tools. Okay. First tool we're going to use is it's a WNMG. This particular holder and this tool I got from Dennis Nolan at Niagara Cutter. And thank you, Dennis. So it runs real good. So we're going to use that. That's the first tool we're going to use. The next tool we'll use is this radius cutter. This is a Kennametal, or it's a Hurdle, I'm sorry, 1040 M. RGNL 1040. It's got a 1/4 inch radius, and we'll use that to cut the radiuses. And then the third tool we'll use is this ground cemented carbide, and we'll use it for all the radiuses. We'll have to flip it over to the other side when we get to that point though. I got to get some eyes on. Can't do this stuff without some protection on your eyes. You ain't got one set of eyes, guys, so don't mess around with that. All right, so we're going to be running this at 95 RPM. All right, and then on my machine, that's all right, we're going to be running this at 95 RPM on my machine. That setup is upper gear in A, low, and set on 95. Okay? All right, so the first thing we're going to do, here's how we want to tighten this. I'm going to touch off on this face, right here, and register a 0, and come back and we'll face this off. So that's the first op we're going to do. So let's spin it up. Well, got to go start the phase converter. Okay, again, first thing we're going to do is we're going to touch off here and we're going to register a 0. So we got to do a couple of things first. Let's make sure we're set up with the cameras. Okay, get our tailstock in place. All right. Got to make everything as rigid as possible. So we're going to come in here and we're going to touch off. Alright, there's our 0. This is my suicide cam. I'm going to come up until I touch, back off. We got just like about 50 thousandths we got to take off of this thing. So we're going to take half of it in the first shot. Moving something. Let's try this again. This one's really bad. Guys, hello. I need to do a little something first. let's get this thing right. All right, there we go. So we're running about 95 RPM. Most of these are cleaned up. Some of them are pretty bad though. This one we may have to take a little more off than the rest of them. Just about all of them has had some inclusions in them. So, alright, we're going to go to 0. Let's see what we got here. All right. So what we're going to do is we're going to do another 20. What's going on with this one? It apparently we didn't get it machined enough and roughed, so it's rating 2 inches 535 and 2 inches 530. So we're going to take another 20 thousandths off to get it to 2 inches 515. We're going to run it around 2.5 inches, but I'm trying to face off to what Keith had there, and so this one we're going to have to go a little more, and then we're going to have to clean that up some. So let's go another 25. Man, I hate when my feet. down to 2 inches 5/18. So what I'm going to do now is I'm going to go inside and clean that inside up. Clean this face up a little bit. Most of the time it's been running pretty good. This one, I don't know. It looks like it may be all right. We're going to come up, we're going to take, well, I'll tell you what we need to do to start with is we need to take a reading on it. And grab my 12-inch mics. And so what we're going to do is this should be 11.5 inches. So take these mics and load them this. All right, so we're at 11. We're 11.5.5. So 11.550. Sorry, 11 inches 510 thousandths is where we at. So I'm going to come up here and touch off. And we're going to clean it up, but we'll start off. Okay, we're going to move in 10 thousandths.